we are going to look at graphing still our sine and cosine curves, but now we're adding some more pieces to it. So far we've changed the amplitude, which is A, and then we've also changed the period. In this case, just for today, the period's always going to be 2 pi, so we're just going to have a 1 in front of our variable here. But now you see this D and C business. So what do these do? Well, C, we'll start with that because that's actually the easiest thing. If you have a value for C, that just takes your whole graph and it just shifts the whole thing up or down that many units. So if I have a +2 on the end, I'm going to graph my sine curve like normal, and then I'm just going to literally take every point and move it up 2 units. If it was a -2, I would just drop it down 2 units. So that's what the value of C does. It's going to shift graph up or down. Obviously up if it's positive, down if it's negative. And it's just however many units C is. Okay? And then D is a little bit weirder. That's called a phase shift. So that's where we're going to be taking our graph and we're going to be moving it left to right. Now, what's confusing about this is that the general formula has a minus here. So that means if you have like x minus pi, that actually means to move it pi to the right. So if you see a minus here, you actually do the opposite of what's in there. So the D is going to be a shift left or right. Okay, and it'll be the opposite of what you see. So in order to best kind of understand this, let's try one of your examples on the worksheet that I just gave you. We're going to pick one of the easier ones. So if you actually flip to, maybe we could do 4. Or should we, actually let's start with 9. 9's super easy. So if I ask you to graph this, y equals sine 2 theta, do you guys know how? Yeah, you just did it on your quiz. See how there's I'm adding 2 to the whole thing? Same thing as adding 2 to the end, right? Right? It doesn't matter if I have it in the front or on the end. So same idea. So what we're going to do is we're going to graph this just like we did on the quiz. And then I'm just going to shift it up 2 units. This one's not moving. There's no phase shift here. I'm not moving it left to right. So let's try this easy example, and then we'll try the tougher ones. Okay? So we're going to graph sine of 2 theta like we normally do. So if b is 2, that means the period is pi. And luckily on my graph, they already have a pi. They already have my quarter points. So everything's good. My amplitude's 1. This is sine. So I'm going to graph just like that. And I might as well just continue the pattern, just so we have 2 full periods shown. So there is my original graph, right? And then, because there's this +2, I'm literally just going to take each point and bring it up 2 units, okay? Now, be careful, because sometimes, in this case, each box is 1 unit, but sometimes we do like 1 unit is 2 boxes. Be careful. You always want to go up the number of units, not necessarily the number of boxes. In this case, though, they're the same. So my starting point is not going to be here anymore. It's going to be here. So every point just gets shifted up 2 spaces. You see that? Exactly. You could. Sometimes, though, it gets really confusing. Right, exactly. Sometimes it gets confusing when you're doing both. If you're going to move it and shift it left or right, it can get confusing where to start them. So what I need you to do, however you're going to graph it, just indicate to me what your final graph is, either by using a different color or designating it or whatever. I don't really care about your initial graph. I just care where you end up. No, I don't need to see it, but I do need a good final graph somewhere on there. Okay, let's try one that has a couple of things going on, like number 2. And that might be as far as we can get today. So this one is not being shifted up or down at all, but there is this phase shift going on here. So what we're going to do is we are at first going to graph this, y equals 4 sine theta. I already know how to do that. But then I'm going to account for this. So let's start off by graphing this like I normally would. So that means I'm going to go between positive and negative 4. 1 period is 2 pi. Oh, my quarter points are there. So I'm ready to go. Sine, so it's going to start at 0. Up, down, down, up. So there is my normal graph. And I guess we might as well finish it. But now I have this phase shift in here. If it's a minus pi over 2, then it's really a positive pi over 2, which means I'm going to go which way if it's positive?
Right.
To the right. Right. If it's positive, you go to the right. If it's negative, you go to the left. So a number in here with the parentheses is left or right. It's a number on the outside that would tell you up or down. Okay? So there's the difference. So if I'm just glancing at number 4, plus 1 is going to tell me that's up or down. This pi, there's something else going on here, but this would tell me left or right. Inside the parentheses, left or right, and you're really doing the opposite of what it says. Outside, you do exactly what it says, and that's up and down. So what I need to do is I actually need to move each of my points pi over 2 to the right. So if I look, pi over 2 is 2 boxes on my graph, right? See that? So basically, I'm taking each of these dots, and I'm going to move them to the right 2 boxes, because on this, 2 boxes is pi over 2. You see that? Then you got to figure out how many it is, and then it can get really nasty. So let's enjoy it while it's easy.
You're going to make it hard?
Yep.
What?
Well, I don't make it hard. The graphs just are hard. And okay, and if I had come back to from over here, it would have landed here. So now I've got this going on. See that? So it's the same graph, but everything is shifted to the right, pi over 2 units.
This isn't that hard.
Yet. It gets tougher. Not that you can't do it, it's just there's going to be more steps involved. And I think, was there one more on here that we could do today? I think so. So if you want to try, oh, that one is a little tough. You know what, I'm going to make a little change. Look at number 10. If we just change this, instead of doing plus 2 pi over 3, let's just make it plus pi. So cross out the 2/3 part. Just make it plus pi. Now it's something you can do. So that's your homework, just this one graph. So yes, number 10, that's it. So I would first graph 4 cosine theta, just like you normally do. And then, what's this plus pi going to do to the whole thing? Careful.
Move it right, or move it left.
Move it left pi units. In the parentheses tells you left or right. And since it's positive, you actually think the opposite of it, so you're going to go left pi units. And then this plus 2 on the outside means move it up 2.
There's no left on the
Really
graph.
annoying that they didn't make it.
Yeah, but you can take like these points and move them left.
You can't
You know what I mean?
origin point and move it over positive.
Right, but you can take all these points and shift them over.
So just do those ones again.
Yeah. Guys, remember, the sine and the cosine curves go on forever. So they don't actually start at the origin. It's just we start graphing it at the origin. But when you shift them left to right, it's an endless wave. So they always continue. There's always more points to graph. So try number 10. That's the only thing you have for homework. And then we'll do the harder ones tomorrow.